Welcome back to another episode of Oxygen Not Included, everybody. Made a few changes to the setup we had for magma tank on our soon-to-be petroleum boiler. I wanted to change it up just so that the reservoir would fill up a little faster, and then the dropper here I built so I knew the distances and everything, but this is going to take a little while to fill up because I want it to be all the way up to this level before we start constructing the petroleum boiler. So I did a few other things getting prepped for it. I moved our power up out of the base. It was actually overheating, and I was kind of being a derp about it. I thought it was just the transformers overheating, but what I'd done, and I'd forgotten to put insulated tiles here. So the heat from the magma was hitting this door, and it was spreading out, and it was heating this whole section up. And it's gotten back to pretty much to normal now, but this 1600 degree heat was transferring through that steel door straight out into the base. So I moved the power all up to the top here, so we have a little bit of a power grid started. It's probably going to get shifted somewhere else, but for now, that's where we're putting it. And then I insulated that corner of the base. I got to go around and insulate the rest of it so we can start working on temperature management a little better. But I also have a battery bank that I got started on. We're going to be shifting this power out of here up there so that we have space to put in our boiler. So I just wanted to have it laid out for beforehand. The other thing we need to have set up for the petroleum boiler before we can really start building it is two things. One is we need aluminum, and I had already set up this aluminum volcano tamer, and so we're getting a stockpile of aluminum here already. This is about to go active again, so this I need to make some more changes to make it so that this cools off the aluminum instead of it just pulling the aluminum out and dropping it. But the aluminum will come out. It'll end up being about 150 degrees right now, which is fine, because once we use it to build with, that heat will disperse very quickly. I want to cool it off a little more, but that's not a priority. But so this will run very shortly, providing us with a large amount of aluminum over the next 50 cycles once it goes active. The other component we need for a petroleum boiler is the crude oil. So I came down, I changed this up a little bit, I lowered everything down so that we had a nice even roof. That is, we're just finishing up this last corner, but basically all the drainage will come across. We're slowly getting rid of all the drainage issues so that this will be a non-issue pretty soon, but for now it's just cleaning out all that extra water coming down from the base as we finish doing all of our cleanup in certain sections. I moved the liquid lock over to this side using a crude oil lock and vacuumed this out. That way there's no heat transfer from this biome up into the base. You can see that there was a little bit that was there from before I got it finished, but it's dissipating, and base is staying nice and cool. This heat, I think, is just residual heat from what was there. I don't think any heat's escaping here, but we got to look into that. Anyway, we had 3 oil wells. I set up some pretty simple designs here. The oil well gets water fed into it. It pumps out the natural gas, and it will put out oil at a pretty constant rate. The oil is set up so that it keeps a nice little layer of oil across the bottom of that oil well. So as the oil well heats up, it transfers the heat into the oil rather than into itself. Because if it gets too hot, it'll cause the water coming in to turn into steam, which will mess up my natural gas pumps. This temperature shift plate, I think that idea was still from Francis John, but I'm not sure. It's hard to remember where you see things, but I just have a temperature shift plate there, so as the oil comes out, it helps to shift the temperature right into the oil. But as this fills up, it comes across here. It keeps a seal here because this liquid always stays just above empty, and then it drips off the edge. So I'm pretty sure this is going to hold. We may have to change it up if it doesn't and the gas starts to escape. But then I repeated the same thing over on this side. This one's a little different because I had a little less space at the top, but works the same way. The oil comes out, builds up across, seals itself, and then the excess drops down into the reservoir. I am starting to get this all leveled out so that I can drain the whole thing then eventually. But and then this was already our natural gas pump, and then this is the one I'm working on over here. The only thing that's different is that there was a bunch of gas that had escaped into the surrounding area, so I sealed it all up, and it goes all the way up to this seal, and this is being sealed by the oil. And so I'm not going to change this at all until I get all this gas pumped out. In fact, I'm probably going to temporarily cut off this water. So I don't want this running because then it's just going to keep putting out more natural gas. I want this to pull a vacuum beforehand, and then I'll seal this up, and then I'll continue to excavate out the rest of this oil biome. And we'll have a nice steady supply of oil to pump into our petroleum boiler. Between the three of those oil wells, we'll have a steady supply adding to this reservoir of just under 10 kilograms a second. And the design we're putting in up here will handle 10 kilograms a second of petroleum or crude oil getting turned into petroleum. So we'll get a steady supply of petroleum, and we'll set up some petroleum boilers or petroleum generators from the boilers. So a lot of little pieces to come together. A lot of waiting on time because we got to wait for this to make us enough aluminum for what we need. Since it's about to go active, it shouldn't take long, but it's a matter of waiting for it to build enough for us. 5 tons might actually be enough, but this we need to wait for the magma to build up in pressure so that we have enough that this will keep it steadily supplied once we get the oil flowing in. This is a little thing that was just a little bit of overkill that I thought was funny. I have all this little mini vacuums above each one to pull out air as soon as anybody walks through. It's super overkill, but it was kind of fun to set up. So this is also all vacuumed out. But once this is filled up, we'll start building a petroleum boiler. But beforehand, I'm going to work on moving these up to our new power brick we're building up here to get them out of our way. I'm considering moving the oxygen generator somewhere, but that would be a lot of hydrogen and oxygen to move if I did that. So we'll see. But I'll be back once I get this coal generators and hydrogen generators moved up to their new home up here. We've gotten our old power plants here removed. We're slowly working on getting rid of all the other automation and stuff that was built around it. And then we moved those up to here. I didn't put a power control station in. I only ever had that in the first place to get that achievement. Now that I have it, it's gone. I don't think the power control stations are worth the time and effort because they require a lot of duplicate time. They require refined metals, and as I said before, you can get more power out of them, but getting more power, that adds a little bit of efficiency, but at the cost that it has to be done at, it's just not worth it to me. And if I need more power, I can just increase the size of my power plants. So I put in 6 coal generators, which I think may be overkill, but they're there in case we get to that point. They'll power everything back up pretty quickly. I reran the coal line from our storage so that that's automatically up there. So again, no duplicates have to fuel it. These auto sweepers are powered off the main grid, and coal will always be there. Hydrogen, I redirected up past the power plant. It's coming straight from our storage, and it's, backlog's already building up. Uh, and then I just set up the automation so that off of our main battery bank here, we have this one's doing 90/40 and this one's doing 90/30, just like they were set up before. So they keep running power until the batteries are at 90%. Once the batteries hit 40%, the hydrogen generators kick in. If they don't provide enough power to keep it up and it drops down to 30%, then the coal kicks in. We have to put in our natural gas generators on the same system. We have to make a decision whether we want to move them or if we want to keep the power grid running all the way across. I'm pretty sure I want to move them. The issue is I need to design something so that they drop out. The carbon dioxide is no issue. I can pipe it over here just fine, but they put out carbon or polluted water at 67.5 grams a second, and I need to set up a system to collect it. Right now, that all just gets dropped down into our drainage ditch down here, and I do want to get rid of that system anyway, so I think moving it up here is a good idea. Just going to have to put in some kind of system where we collect that polluted water and pump it into our storage tanks, which is not a big problem at all. Ideally, it would probably be better to have them built so that the storage tanks are below them so that we could just drop it in instead of having to spend the power to pump it out. But power's not an issue, so I think that's our next step. We're going to move these natural gas generators up there and reroute everything for that. I'm going to finish getting rid of this whole area and getting it cleaned up. I have to move these power transformers and connect them up to the main grid up here so that we don't have them here, and then that will free up all this space for us to build our petroleum boiler. So I think that should be enough space. It should actually be more than enough space. So I think we're going to, at least for now, the SPOM is safe. It's going to stay where it is. And the gas storage, though. It all might get moved later. I need to... Some water got into this natural gas storage from the steam that came in from our oil reservoir down here when one of these overheated, so the water coming in got over 100 degrees and it boiled in the pipe and it turned into steam, which got sucked up into our gas pipes. It looks like it actually happened right here. So I think that maybe that might be the problem here. It might have been... I'll have to look into this some more. But either way, water was getting in here. I have since fixed it, but I got to figure out why we're still having issues with it coming through. So I'll look into that, and we'll get that fixed, and we'll get the storage fixed. The last thing we want is to get so much steam getting pumped in and turning into water in here that we break our storage. Because we don't want to have 1,000,000 kilograms of natural gas per tile breaking out into the base. It would be quite a mess. So, okay. So I'll come back once we get this all cleaned up and get the natural gas generators moved up to be added to the system up here. So, see you shortly. I discovered what our problem with the steam was. I'm correcting it now. So for this oil well, we weren't having any issues at all. And it's because the water coming in was in this pipe. It sits in this pipe inside the room, but this room is temperature controlled because we have the crude oil cooling off the oil well So the temperature in here never goes above 85 degrees. So even though there's water sitting in that pipe, the water never gets too hot. The problem is that occasionally these oil wells back up, and this water sitting in that pipe will start to heat up because it's not moving. Inside here, it's not an issue because the heat never gets quite hot enough to turn that water into steam. Over here, I had the pipe come in here. It was going across this room and into here. So what I did for now is I just put insulated tile over where that pipe's going. I think I probably could have just changed the type of the piping, but it's fine. The duplicates can get through underneath for now. And so we should not have the issue. I'm just going to do that to test to see if that is in fact the problem. And if it is, then we will figure out a better way to handle running the pipes. Probably just using ceramic piping would be our best. I think that I currently have it just with granite insulated pipe. If I have it with ceramic, I don't think the heat will transfer enough to cause an issue. This little dude I had set to mop because there was water that had gotten down there. So now we got all the water mopped up. So we're going to let that run and we will see what happens as far as any problems we have with it. This oil well on this side of the map is going to be the same way. So once we turn this on, I'll put a... in fact, what I think I'm going to do is just do some granite or ceramic piping here. Well, I'm out of ceramic. Why am I out of ceramic? Let's check that out. Did I run out of clay? We have clay, it's just not getting here, so let's see. This is on a lower priority. Let's put this on priority 9 to get duplicates bringing me clay down here. Because I want this to be running, making me ceramic. Okay, we'll let that run. We'll get that done. I'm gonna, on this side, we will, instead of blocking that pipe, I will just turn it into a ceramic pipe and we will see if it causes any issues. This one we're not turning on until we get rid of all this gas, so still be a little while. Looks like we're backing up our gas pipe a little bit, maybe. Yeah, let's cut off this. Oh no, this input's occasionally turning off. It's just taking its time to process all the gases. No problem. We'll let that run. We'll get back to finishing up our power system. Last thing I was testing here, I wanted to see which block the water from the natural gas generators actually goes through. So it's a second one over. Having a heavy watt joint plate there is not going to cause water to back up, which was the last thing I needed to know for this design, because I need to put in heavy watt joint plate to go up. So that we can get the power lines run up to the generators. So basically all I did is I made it so that the floor underneath it is mesh tile. There's mesh tile here. We'll get this built in so the water from the polluted water coming out of natural gas generators will drop down here. It'll spill over into here. And in here we will have a pump that takes it down and drops it off into the water tanks. Pretty simple, pretty straightforward. So we'll be back once this is all built up. All right, just like that, we got the last few little bits and bobs in, and this is running, and we can see the polluted water comes down, flows across, drops off into here, and gets pumped out immediately. We're going to get that sealed up. Um, yeah, we're gonna have polluted oxygen in there forming from the polluted water. That's fine. A few little pieces of automation wire that needs to be connected, but we have the gas coming in from our natural gas tank. We've disconnected it from this old setup, and then we have carbon dioxide getting come down to our carbon dioxide tank. So these wires are starting to get a little more cleaned up, which is nice as well. The polluted water just comes straight down and gets dropped off right here into this line that's already there. One thing I did notice while I was cleaning some of this up and moving it around is that the main reason I have a problem with ceramics running out is that I have a bad habit of just running ceramic pipes all over the place. I don't think either of these are, because I think this is before I had ceramic, but I had a line running from here all the way over to here that was all ceramic, and there's no need for it, so I just ran some regular lines. I need to get into the habit of just running regular gas lines, and then if I have a temperature issue, then putting ceramics in that spot instead of just running an entire line. It's all expensive materials. So this is all okay. So the automation's in place now. So this one's set up at 90-50. So basically 50% this turns on. If this can't deliver enough power, then at 40% the hydrogen generator turns on. And if this can't deliver enough, then at 30% the coal generator turns on. And then, so this is like our last ditch resort. Eventually we'll have petroleum generators too. We'll just add them in. I kind of designed this the way it is so that if I decide, hey, I want to have a little more power from each section, I could make another layer on top if I wanted. I don't think that I'm going to reach the point where I need more than 6 of these generators at a time ever. By the time I get to the point where I need that much power, I will have a solar power grid installed. So I think this is going to do us, but if we need to, we have space to put in one more layer so we can have 9 of each generator. So that means we have this power needs to build up. These are just down because they just got connected. But since all the batteries are all connected directly, we won't have any issues where some batteries are reading different than others because of the distance between them too, which is a nice thing about centralizing our power. So the next step I'm working on is moving these power lines so that they're not quite so spaghetti. So like this one, for example, I just connected over here, so I can cut this one out and we can get rid of this old line that goes all the way through all the other lines. And the other reason that we're doing this is that I want to shift some lines over because I need to get 2 more transformer lines to come down to here so that I can rip out this old power spine that goes down. I still am going to have the spine that comes through somewhere because I want to connect it to the main one up here, but I'll probably run it straight across and down and get rid of this spaghetti of all this. But all the pumps and everything down here in our gas storage system are connected to the main grid right now, and they're using a total of 1440 and 1920. So I got to get a couple lines down here for that. But we will see some of this stuff won't be here anymore, and we can get rid of some of the power. So we'll clean that up as we go as well. So so we will get that little bit cleaned up, and then I will show you that before we are done. Just showing a little progress here on the power grid cleanup before we call this episode an end. We are just kind of shifting wires down and consolidating items together so that we can have the least amount of cables coming out and keeping the cables kind of even. I'm not being too particular about the wires in here because this area down here is going to be changed dramatically pretty soon. I'm going to be moving the food to its own production out of here and into its own section, and I'm going to be building a permanent base for our duplicates for too long. So I don't want to worry about the grid being perfect and then just rip it all out a little while later. But some of it was nice to get changed out because we were still using some of the basic wires from the beginning, and some places we had wires that were going all the way across, causing us to have to do all kinds of wire bridges. So getting rid of those was nice, and we'll get the rest of these put up. So right now we have 3 lines that come down here. We have the 2 that come off here, and then another one off here to power a few other things. So we'll connect those up to these 3, and then we'll shift these 2 lines over to the 2 here. And I think that's going to give us enough. We may have to put in one more just to get everything powered that we have. But we'll do that in the next episode. We'll get this area all cleaned up. I'll probably do that in between episodes. Just get this cleaned up so we're ready to start building on the petroleum boiler next episode, and we'll get all this old stuff ripped out. We should have all of our oil set up by then. We're still having issues here with this water. We're going to have to do some research and figure out what's causing this steam to occur, because that's really messing us up. But I think for now what I'm going to do is clip this wire so I don't have water coming in, and we'll just run off this one oil reservoir that's not having any issues for now, and we'll get it figured out before we go much farther. And this one will get the gases all pulled out. So we'll have oil reservoirs fixed up. We'll have the power grid cleaned up, and we'll have all the old stuff ripped out of here so that we're ready to get building during the next episode. And just to check in on this is the last thing for this episode. Our aluminum volcano has been active for about 20 cycles now, and we were at 5 tons of aluminum. Now we're up to 11. It's still pretty hot, so we're going to have to put in a system to cool it down in the future. But for now, that'll be all right that we could build with that, because it'll lose its heat as we build with it. I already have the system designed for how I want to do this, with you having a chill chamber to chill down the aluminum before it comes out. It's just a matter of getting it put in place. So we may do that before we finish or start on the petroleum boiler too, just to make our life a little easier. But that's going to do it for today. I'm excited to get it started on a new project. I feel like we've been doing a lot of little minor things to get ready for this project in the last few episodes, but we should actually be ready to start producing petroleum in the next episode. So we'll hope to see you then. Bye-bye.